the majority of Earth's heat comes from the sun in the form of radiation. This radiation travels through empty space to Earth. Once it reaches the atmosphere, a small portion is reflected or bounced back into space, while the other portion is absorbed by the surface of the Earth. This portion that is absorbed helps heat the Earth in two ways. One way that it helps heat the Earth is through conduction. Conduction is when all of these particles on the surface of the Earth absorb the energy that came from the sun, and then it passes along that energy by all of the particles hitting each other. Another way that the sun's radiation helps to heat the Earth is through something called re-radiation. Re-radiation happens when the Earth absorbs the sun's radiation, and then it also radiates that energy. That radiation is mostly trapped in the atmosphere, although some of it can actually leave Earth. When it's trapped in the atmosphere, that radiation is either absorbed from the atmosphere or sent back down to the surface of the Earth to be absorbed. Re-radiation plays a big role in helping to heat planet Earth. Here you can see two circles that are about the same size or have the same volume. As you can see, these circles have particles inside of them. They do not have the same number of particles. They have a different number of particles, also known as mass. We can compare these two things, volume and mass, in what is known as density. Density refers to the number of particles that are in a particular amount of space. We can also use density as a ratio of the mass of an object to its volume. The object that's on the left in this diagram, this circle right here, is considered to be more dense than the object on the right. This is because it has a greater number of particles in this amount of space than our second object. Objects that are more dense feel heavier than objects that are less dense. If these two items were something like gold and feathers, we would be comparing the same volume of these objects, but as you can see, the gold contains more particles in that amount of space than the feathers. This helps us understand why when we think of gold, when comparing it to something like feathers, we think of it as being heavier than something like feathers. It's simply because gold contains more particles in the same amount of space than feathers. The last method of heat or energy transfer is convection. Convection involves fluids only. A fluid is anything that can flow, as in a gas or a liquid. Convection cannot happen with solids. Convection involves heating a fluid and the process of that fluid becoming less dense and rising, only to be cooled and then becoming more dense and sinking. The example on this page involves water. The water is heated by the heating coil right here through radiation. This radiation heats first the pot, which through conduction heats the water inside of the pot. Once that pot has been heated, the water can then go through the process of convection. So let's walk through this process using this pot as our example. Remember, initially, radiation occurs from the heating coil and it begins to heat this pot. The molecules in this pot begin moving very quickly and they heat the rest of the molecules in the pot. When the pot molecules begin moving very quickly, they start to hit the molecules that are in this water. That causes some of these water molecules to speed up and become heated. In this example, that starts on the bottom. Whenever a material is heated, it becomes less dense. Think back to the experiment that we did with layers. Which material was on the bottom? Was it the more dense material or the less dense material? It was the more dense material. So if the water molecules on the bottom become less dense, can they stay on the bottom? The answer is no. Less dense materials need to be above more dense materials. What does that mean for our water? That means that the water molecules that are on the bottom are in fact going to rise to the top of the water in our pot. When they rise, they are further away from the heat source, which means that they begin to slow down. Think about what you know happens to particles when they slow down. When they slow down, they become cooler. When they become cooler, they become more dense. Again, think back to the layering activity we did in class. Was the more dense material on the top or on the bottom? It was on the bottom. So this more dense material that's now on the top of our water needs to go where? It needs to go down. So the more dense material that's on the top will begin to sink. When it sinks, it now encounters the heat source. When it encounters the heat source, it becomes warmer. When it becomes warmer, it becomes less dense and rises. When it rises, it slows down, cools off, and becomes more dense. When it becomes more dense, it has to sink. This process of warm fluid rising and cool fluid sinking is the process of convection. Radiation, conduction, and convection all work together to help keep our planet warm. Radiation initially comes from the sun. This energy travels through Earth's atmosphere to the ground, where conduction helps transmit that energy to all of the particles in the ground. Remember re-radiation? Re-radiation helps get some of this energy from the sun back up into Earth's atmosphere, where convection helps that heated air travel upwards where it is cooled so that it may fall and be heated again. To refresh, the sun gives off radiation. That radiation heats the surface of the earth. Once the surface of the earth has absorbed this energy, it uses conduction to spread that energy among the surface of the earth. The air above the surface of the earth gets warmed. As warm air expands, it becomes less dense. This makes that warm air rise. As the warm air rises, it cools down. Cold air is more dense than warm air. Therefore, air that's now cold has to sink where it is warmed again. Once it's warmed again, it will rise into the air where it will cool down, become more dense, and will sink to be warmed again.